Okay, so now what we will do is we will have BGP in a different fashion. What we will do is we will have these two loopbacks on router 1 and router 2 now, and a basic connectivity from here. Now, if you want to have eBGP neighborship, the things that you have to understand is by default the TTL of eBGP is 1, and for you to have reachability from one place to another, you must have the route in the routing table. Route must be reachable. You must be in reach. So if I want to have neighborship from my 1111 to 2.2.2, I must have the route to reach 2222. So routing protocol will come into picture, or you require a static route, or else, and one more thing, there should be, if you have this one, there should be the source that is specified. Source specified. What do I mean to say by that? Let's explore that. Now here we will have eBGP neighborship from router 1 to router 2, but using our both loopbacks over here. I will use my loopback and connect with his loopback, right? So basic IP addressing, I will simply get rid of my previous loopbacks. No interface loopback 1, no interface loopback 2, no interface loopback 2, and no router BGP 100. Simply I'll go there and say no router BGP 200. So I will have nothing. Show IP protocols. I don't have a protocol. Do show IP protocol. I don't have a protocol. And in here also, show IP protocols. I don't have a protocol. Just the basic addressing has been done. Over here, I just assigned 10.0.12.1. Over here, I assigned 10.0.12.2. Okay. And now I will create 1.1 loopback. 1.1.1.1 and 2.2.2.2. So how will I do that on router 1? I'll say interface loopback 1, interface loopback 1, IP address 1.1.1.1, 255.255.255.0, and exit. Now here you require a routing protocol, or you require a static route. So what I will do here is I will say IP route 2.2.2.2, 255.255.255.255. I'll say, so this is a static route if you want. And you can say the neighbor. So for me to reach this network 10.0.12.2, it's very straightforward. Just a moment. Yeah, so we will give this configuration now on your router 1. Control C. Let's go on router 1 and let's paste it on router 1. I am creating a loopback, interface loopback, IP route. It is this router. Sorry, it's 10.0.12.2. It's my neighbor. So simply I told my router, for you to reach that destination, kindly forward the data to 12.2, right? Similarly, I will create another loopback on router 2. It's 2.2.2.2, and I will tell him, for you to reach the neighbor's router 1111, you will send your data to 12.1. Yeah, this is correct. So I am router 2. This is the configuration for router 2, and router 2 has created a loopback. And for him to reach R1's loopback, he will send it to router 1. Sorry, I'll go on router 2 and I'll just push these configurations. So simple. Now R1, the first criteria that we wanted to understand is the route must be reachable. It's okay. Route is reachable. Can router 1 reach router 2's loopback ping 2.2.2.2? Yeah, he is reachable. Now, anytime you go from this router, for example, just taking another example, anytime, sorry, print screen, let's go back. Anytime you say, I want to ping, for you to ping from here to here, if you say I am pinging from here to 2.2.2.2, you take the source address of this interface. So once you go 10.0.12.1 will be your source. So if you want to ping from the source of, like assuming that there is a PC over here, There is a PC, and this PC has this IP address 1111. This PC wants to ping. How will you check from your router? So you have to say, like on router 1, you have to say ping 2.2.2.2 from my source is loopback 1. So it is taking 1.1.1.1 as the source. This is a very basic thing. Whenever I send my packet outside, I will take my exit interface into consideration and I will send my data out. And he will also give me a reply on 10.1.12.1 over here, like this. So the three parameters that we wanted to specify is a route must be reachable, route reachable. Second is the time to live value equals to 1, and you must specify the source of the interface. Now let us update the source. Let us see what happens after that. Let's go on router 1 and router 2. Configure terminal, router BGP 100, neighbor. Now where am I supposed to form my neighborship? With 2.2.2.2. Neighbor is 2.2.2.2. He is in the remote autonomous system of 200. This is how I will try to form my neighborship. But this guy is not activated router 2. So let us complete the configuration. I will say neighbor 2.2.2.2. I will say update source is my loopback 1. And while I go outside, I will take my update source as 2.2.2.2. Because if I do not specify this update source, my update source will be 10.0.12.1. Similarly, on the other side also, I will go on my router 2 and I will say basic BGP configuration, router BGP 200. I will say neighbor 1.1.1.1 remote autonomous system is 100, and my neighbor 1.1.1.1 will use your update source is your loopback 1. So for me to form neighborship from here to there, I will also use my loopback. And once he checks, okay, what is my loopback? It is 2.2.2.2. So are we forming neighborship here? Show IP BGP in here. Show IP BGP is not in here. Show IP BGP neighbor 1.1.1.1. In here, it says there is received and sent is not there. I have created. See, the state is idle as of now. Now, technically, what will happen in the backend that the moment I send out my update from 1111, it reaches over here. The TTL is 1 and the TTL will be decremented over here by 0. For example, I receive a TTL of 1. Before I forward it to my loopback, I will reduce the TTL of 0. So the moment the TTL of in a packet is 0, the packet will be discarded. That is why you need to change the TTL value to be a higher value than 1. So what you can do is you can specify 3 also. So you can say router 1. While you are sending an IP packet of for this neighbor, set the TTL value to 3, for example. So you send it with 3, he will decrement it to 2, then it is valid. Usually what we will do here is we will go on router 1 and we will say neighbor 2.2.2.2. You will say eBGP multi-hop. eBGP multi-hop, enter. Now this increases the TTL value up to 255. Actually, that is not recommended. You should be very precise, but by default, this will give the time to live value for 255. Now, similarly, here also you have to specify router BGP 200. This is my BGP. Neighbor 2.2.2.2. Sorry, neighbor 1.1.1.1. eBGP multi-hop. Now, if you see show IP BGP neighbors, see something went up. Exchange is up immediately. He has sent and received one and his capability state is established. So it is very important to understand these 3 parameters. If you want to form eBGP neighborship with loopbacks to loopbacks, by default, it will not be possible. If you have to do this type of neighborship, you need to have a routing protocol in any routing protocol, EIGRP, OSPF, whatever, and the TTL must be increased and the source must be properly specified, or else BGP neighborship will not come up. And there are many ways to debug it and all, but debugs are not allowed in production. So you have to be very precise. In CCNA, we are not supposed to see BGP more, but this is the basic implementation of BGP. Now you can also have EIBGP. By default, IBGP has a TTL value of 255, so nothing has to be done. So this is the very basic implementation of your border gateway protocol.